This lesson is probably going to be review for most of you, but just in case maybe you've forgotten or maybe you just missed a day last year, these are going to be your key features of quadratics. So our learning target is I can find key features of quadratics. Okay, so the first thing we need to talk about is what standard form looks like. So all quadratics are going to be written in this form. Ax squared plus bx plus c. So wherever I write a, b, and c, those are just numbers. Those are like little placeholders. We don't know what the numbers are, but they're there. And then the x squared and the x, those are actually variables. So you will have an x squared in there, and usually you're going to have an x also. Okay, that's going to be a bigger thing like later on in the semester. Right now, just need you to know that's what I mean by standard form. Okay, so then the graphs. When graphed, a quadratic equation creates a U-shaped curve called a parabola. Please don't call it a parabola. It's annoying and you sound ignorant. Okay, it is a parabola. Okay, so there are two types of parabolas. So I want you to use your graphing calculator or use Desmos. And I want you to go ahead and sketch both of these functions, and then we'll talk about them. So, sketch them in 1, 2, 3. Okay, so here's the difference. If a, so the number in front of x squared, so you don't see a number, so that's just an understood positive one. So if a is positive, then the parabola opens upward like a smile. So now we have a happy parabola. Look, he's even sticking his tongue out. Yay! Okay, if a, the number in front of x squared, is negative, so that's understood to be a negative 1. So if a is negative, then the parabola opens downward like a frown. So this is an angry parabola. Alright, so that's the difference. So the number in front of x squared, the a value, determines whether it's a happy parabola or a sad parabola. If it's positive, it's going to open upwards. If it's negative, it's going to open downwards. I don't know why that moved down like that. Okay, so then there's this thing called the axis of symmetry. So we talked about that in the functions unit. So it's a line that's going to go straight through the middle. And the formula for the axis of symmetry is x equals negative b divided by 2a. So remember, we talked about standard form of a parabola is like this. So when I talk about b, I'm talking about the number in front of x. So when I say b, I'm talking about the number in front of x. When I talk about this a right here, I'm talking about the number in front of x squared. So that's why it's important to have things in standard form, so then you can use formulas like axis of symmetry. Okay, and then we're going to talk about a vocabulary word called the vertex. So this is a big deal. The vertex is going to be the highest or the lowest point. So when the vertex is the lowest point, that is called a minimum. So if you had a problem like this little point, the lowest one, that would be your minimum. Okay? When the vertex is the maximum point, it's called the maximum. I should have said highest. When it's the highest point, it's called the maximum. Alright, so if you had a grumpy parabola, this point up here would be the tallest one, and that's your maximum. So you're usually just going to abbreviate minimum and maximum as min and max. But know that they are also called the vertex. So when you say vertex, you're not being specific whether it's the min or max. And when you call them the min or max, you're being a little more specific. Okay, so we're going to do this one together. The first thing we're going to do is we're going to find the axis of symmetry. So if you'll remember, the axis of symmetry is this formula. Negative b divided by 2a. So when I say b, I'm talking about the number in front of x. So this is going to be a negative 8 divided by 2 times a. And when I say a, I'm talking about the number in front of x squared. So anytime you don't see a number, it's an understood 1. So this is going to be 2 times 1. Alright, so x equals, what is 2 times 1? 2. What is negative 8 divided by 2? Negative 4. So the axis of symmetry is going to be at x equals negative 4. Okay. And then we have a thing called the vertex. So we're going to find the maximum or minimum in just a minute. And we're going to sketch it. So everybody should be pretty able to sketch by now. So go ahead and graph that function y equals x squared plus 8x plus 15 and draw you a little sketch. So it looks something like that. The axis of symmetry, anytime you have a line that's x equals, it's going to be a straight up and down line. And it would hit at negative 4. So yes, it's a line that goes straight through the middle. And then if you're using Desmos, the vertex is so easy. All you got to do is click on that point. So that point is definitely a minimum, and you just got to click on it and figure out what the vertex is. So the vertex is at the point negative 4, comma, negative 1. And notice how I'm writing these. The vertex is always a coordinate point. The axis of symmetry is always x equals a number. So that's the difference between those. So sometimes I'll say, tell me what the vertex is, and people will say 4. That's not a coordinate point. It needs to be x, comma, y in parentheses. Alright, let's try another one. First thing I want you to do is let's just go ahead and sketch it. So either using Desmos or graphing calculator, graph y equals negative x squared minus 4x minus 2 and sketch a little graph of it. Okay, so now we have an idea. It's definitely a mad parabola because that number in front of x squared is negative. Alright, so let's find the axis of symmetry. So x equals negative, I'm going to do b, divided by 2 times a. Alright, so remember, b is the number in front of x, so it's going to be a negative 4, and a is the number in front of x squared. So there's not 1, it's an understood negative 1. So I'm going to plug it in. So x equals negative, so b was a negative 4, divided by 2 times a is negative 1. So just a little common sense here. X equals a negative divided by a negative 4 is a positive 4, divided by, on the bottom, 2 times negative 1 is negative 2. So 4 divided by negative 2 is negative 2. So the axis of symmetry is x equals negative 2. So I'm going to graph that over here. It's going to be a straight up and down line at negative 2. So there's your axis of symmetry. Notice it goes directly through the middle, which is what you wanted. And then the vertex, if you did this in Desmos, it's so easy. All you got to do is click right there. That's definitely going to be a maximum. And when you click it, you get... Sorry, I'm on a different screen. It's taking me a minute. I'm stalling. Okay, negative 2, comma 2. And remember, the vertex is always going to be a coordinate point. So negative 2, comma 2. Alright, so pretty easy stuff. Desmos makes everything easy. So sometimes you're asked to find a quadratic model. So if you have a graphing calculator, I want you to look at this side. Oh, sorry, this side. So using a TI, that's probably how you learned it last year. But then doing it in Desmos is easy, but it's a little complicated just because you probably haven't done it. So I want you to watch that video on the left. So watch one of the videos. You can watch both of them if you want to, and then we're going to do some problems. Alright, so after watching the video, you should have one way of doing it. That's great. So example 1, a study compared the speed x, so it even tells you, sometimes they don't tell you, but you would have to know. So x represents speed in miles per hour and the average fuel economy y. So anytime we see y, it's going to be average fuel economy. And they labeled it in the table, which is really, really nice. The results are shown in the table. Find a quadratic model in standard form for the data. So after watching the videos, you should know how to put this in the calculator and find a quadratic model, and I just want you to go ahead and write it out So I'm going to pause the video in 1, 2, 3. So I'm going to round, and I'm going to give at least 3 decimal places. So if you didn't round quite the same way, it might be a little different, but it should be pretty much the same. So negative 0.008x squared plus 0.746x plus 13.472. So that is my quadratic model. So anytime I say find a quadratic model, that's what you're looking for. And you're either going to do it in Desmos or the TI-84 graphing calculator. Okay. So we're going to do the same thing, and I want you to find a quadratic model for this data. Alright, so for this one, another labeled table is really nice. When you're talking about x, you're talking about angle in degrees, and when you talk about y, you're talking about distance in feet. So you're tossing a pumpkin, and here is the quadratic model. So remember, I'm going to give at least 3 decimal places, so if you're just a little off on the rounding, that's okay, but it should be close. So negative 0.261x squared plus 22.591x, and I just ran out of room, sorry, plus 23.029. Okay, so hopefully you got the same thing, or at least close to it. If not, you can email me how to do this if it's not making sense. And then here's the last one we're going to do. So you can read the questions. The first thing I want you to do is use a graphing calculator to find the best fitting quadratic model, just like we have been. And then I want you to take it a step further. I want you to predict the change in finishing time when the wind speed is 10. Okay. Alright. So, remember, x is wind speed, y is the change in finishing time. So I'm saying, once you get your model, when x equals 10, what does y equal? Okay, so find your model and then we'll talk. So 1, 2, 3. Okay, so you got your quadratic model. So now you can either put the quadratic model in your y equals and use the table, or you can replace these x values with the number 10 and it'll give you your y values. So pick one to do and figure out what y equals when x is 10. So either plug them in or use your calculator. And I got negative 1.896. Okay, so this should have been reviewed. Maybe using the Desmos to find the function, that's probably new. But hopefully that was a refresher to get this back in your head. So that was key features of quadratics. Alright, email me if you have questions. Bye.